monitoring 2023 conference. And I suggest starting the work with minute silence to honor the memory of all the fallen defenders of Ukraine. Починаємо з хвилини мовчання в пам'ять всіх загиблих захисників України. Так, thank you. Дякую всім. We thank the armed forces of Ukraine for the opportunity to hold this event. Дякую всім захисникам України за можливість проведення нашого заходу і за можливість працювати в такому форматі. And now let me greet you on behalf of the program committee. Dear participants of 17th International Scientific Conference Monitoring of Geological Hazard and State of the Environment. It is our great pleasure to welcome you to our conference. It is the 6th time that our conference has been held under the auspices of EAGE, and the 3rd consecutive year that it has been held online. The unprovoked Russian Federation's war of aggression against the people of Ukraine has been ongoing for 20 months. Despite the military action, missile attacks, bombing, power and internet outages, Ukraine survives, works and recovers. Taking into account the need to rebuild the infrastructure, provide resources of the strategic industries, monitor the environmental condition of the territories where hostilities are taking place, the topic of our conference is and will remain relevant for many years to come. The conference program includes more than 2,000 reports, 2007 reports, which will be presented in 10 sections. To promptly respond to today's challenges, we have introduced new sections. In particular, this year the section monitoring, registering, and assessing the impact of the war begins its work. We are grateful to all partners for their help and support in holding our conference. My special thanks go to the management of EAGE for the support and assistance provided to the participants from Ukraine. I wish everyone fruitful work. We believe in our victory. Thank you for attention. Yeah. And now I would like to invite Edward Viarda, the President EAGE, to greet all the conference participants. Please, Edward.
Thank you so much, Sergey, and I completely share your thoughts and the impact this war has on this particular local conference in Ukraine has not at all wavered you in your activity levels, in your motivation, in your enthusiasm to organize these events. It's very impressive that there are so many participants attending, contributing, submitting papers, and presenting. In all honesty, you are very much at the same level as the EAGE Near Surface Geoscience Conference that we had in Edinburgh, which is not a war zone. So just to bring this into perspective, and I would like to thank you and welcome all participants online and maybe a few in person in Kiev to this very promising looking conference. I've gone in detail through the technical program, and I would like to congratulate you, Sergey, in particular, and your technical committee for putting together such a impressive technical program, and Dimitri for inviting me to have the honor and to present and to open this session. I've prepared actually a few slides, if you don't mind, to bring some thoughts in that I had the last couple of days preparing for this event. Can you see my slides, my opening slide?
Yes, in full format.
In full format, that's how I like it. No, so I'm not only honored to be virtually opening this conference with you. I'm also humbled because normally when I present and I open these technical sessions, I immediately move to the topic of energy transition, which is obviously one of the important challenges, climate change and getting to zero emissions within the world in the energy sector and in the geoscience and engineering communities. And then normally this would be my first slide explaining where the EAGE stands at the moment. I don't know, some of you may have heard, but since February, we have moved from divisions, which implies silos. We've moved to the use of circles that are overlapping. That's one of my pet projects, so to say, where we have these Venn diagrams and showing that we are actually there's a lot of synergies between the oil and gas, geoscience and engineering community, near surface geoscience, and sustainable energy, which is a new one since February as well. But then, as I was preparing these slides, I suddenly came across titles in I think it's your plenary session. I just picked two of them. Detecting war-related pollution of soils as a topic, using magnetic and geochemical methods, and the first results from recaptured outskirts of Kiev. And that made me humble and realize that I should not be talking about energy transition. I think this audience has other crises to survive and to resolve and to act upon. And another example here is the dam explosion at the Kakhovka hydroelectric power station, and the papers. There's many papers I saw on that. So I completely changed course and focused more towards another important topic that the EAGE is working on, and that's rehabilitating the reputation of geosciences and the energy sector. But in this particular case, I would say restoring the connection between geosciences and society. And this is important because across the globe, we seem to be losing relevance in many of our events. We are great talking to each other. We understand between geoscientists and engineers what we're talking about, but to the outside world, we are poorly understood. And I'm focusing some of our circles to reconnect with society and to organize events that have relevance to a non-technical audience and invite policymakers, politicians, governmental regulation officials, etc., as well as the general public. And I'm doing this as part of this 3 Horizon framework, which is coming from an interesting paper by Ian Stewart, which I highly recommend. And basically, all the 3 circles now have 3 roadmaps instead of 1 EAGE roadmap. The oil and gas circle will focus on solving the energy trilemma in energy security issues, making sure the gas keeps flowing, the energy is supplied to drive and to energize the energy transition. And then the energy transition through the EAGE Sustainable Energy Circle has their own path, moving towards geothermal, wind farm development on onshore and offshore, hydrogen, CCS, those kind of topics. But the most important one I want to share with you in the next couple of slides is the Horizon 3, which is the visionary one by the EGE Near Surface Geoscience Circle. And that's all related to societal issues, societal challenges, and that includes war and the effects of these unprovoked attacks by the Russian Federation. So, but it's also about recovery, restoring civilization after the war. And I think you guys are a great example, and to the rest of the EGE community. And I'm going to share and spread the word what you're doing here. So priority teams here are health, water, energy, food, environment, vulnerability of systems and infrastructure, resilience, geohazards, landmines, etc. And the end goal is a safe and just operating space for humanity. So this can be seen as greenwashing if this story is told by somebody from the oil and gas industry. If this story is told by some of you, then suddenly it becomes clear that the EGE and geoscientists in general really care about the future and about a new generation of geoscientists and about the communities we live in. So we need to leverage this special near surface geoscience circle. And looking at your conference, it seems that you're leaning towards a lot of those topics. So that's why I've put it in here. And I've reshuffled these because we are living in the wake of a couple of really disastrous natural events, disasters, like the Pakistan flooding and the Libya flooding, earthquakes in Morocco, recently in Afghanistan, and early this year in Turkey, Syria, but also the Ukrainian-Russia war is not a natural event or disaster, more an anthropological hazard. War is. And I've put humanitarian demining and landmine detection on the top of this list for a reason, because I'm very interested in what's happening and unfolding at the moment in Ukraine. So within these three overlapping circles, we have communities, and these communities, they live in overlap zones. So they're not only associated with one particular circle. They can, like geohazards is basically important to oil and gas exploration and production, new energy as well, and obviously also the near surface where these geohazards live. But if you also look at another community called uncrewed aerial vehicles or drones and artificial intelligence, you can already start to see that the communities are actually the building blocks. The circles are just a mean to organize them. And we want more of these communities, and we want to combine these communities. So a special topic that I have in mind is to combine drone or unmanned aerial vehicles with AI and geohazards, and have a special sessions around landmine detection and clearance eventually. Important is that in the last couple of days, I've read some articles that Ukraine unveiled an unmanned aerial mine detector system, drones basically operating 4 times faster than humans, combining of various measurements, geophysical and remote sensing alike, detecting mines very successfully, and transmitting in a safe way back to the operators, the so-called sappers, from a secure location. And your Ukraine Minister of Digital Transformation has basically said that this will significantly speed up the process. So this was backed by Julia Sviridenko, your economy minister. Sorry for the pronunciation. And basically, you've got a very unique product here, coming out of collaboration between various communities inside of Ukraine, acting on very real life war issues. And your demining strategy will be ready before the end of this year, I've understood. Without demining, you will not be able to fully launch your economy. And this demining system could have a really big impact on the international standard of demining, which is normally very low tech. Let's put it that way. So if you, with the help of EEG, are willing and able to export this unique technology and strategy, and share this demining knowledge and technology with other countries with heavy landmine contamination, this could be a great way to share knowledge across borders, basically. And I've lived in Colombia for quite a few years, where we had huge landmine problems. Egypt is full of landmines, Kuwait as well, and I don't know for sure, but I think Ukraine is climbing this list very rapidly. And I foresee a hackathon or a workshop or a roadshow across the world where some of your experts get together with people from Colombia, Egypt, Kuwait, and Vietnam, for instance, in the different regions, and share knowledge. And that's what the EEG is all about. And that's why you are so important. You're being forced through the very challenging and adverse situation you're finding yourselves in this war to innovate and to keep coming up with ideas, because you have to. In Colombia, this hasn't happened because some of these landmines are in jungle somewhere. In your case, you cannot restart your country. You cannot reboot without having solved this. So there's way more priority here than elsewhere in the world. So that's why you have the technology and they don't. So I would like you to share. So this is the end of this snippet of technical content. I hope you find it interesting. I'm very keen to speak to your officials and to you as a community about this idea of organizing an EEG landmine detection roadshow. If some of you are interested, let me know. I'm all ears. Through Dimitri, you can get my details. We are covering all aspects of geosciences, not only oil and gas and new energy, but also the societal geosciences. We call it near surface, but I'm pushing for a new term called near society geosciences, because I think you will see a lot of presentations in the next couple of days that are very near society and have a lot of relevance. So following our new framework, I think we are well adapted to be very inclusive to all geoscientists and engineers, and also to reconnect with society, to become more relevant and to improve our image at the same time. We are member-centric, we listen to you. We have a focus on some key themes, but we're open to new ones. And one of them is landmine and UXO detection. So with that, I hand over the podium, the stage back to Dimitri, and have a fantastic and active and energetic, inspirational set of technical sessions and conference. My compliments to all of you, and you can always reach out to me for questions and ideas. Thank you so much.
Thank you, Edward, for your very good speech and point of view of what EEG can do for Ukrainian scientists and how Ukrainian scientists can be in advance in other work. Thank you. I think that.
Thank you, Edward. Very interesting information. Now I'd like to introduce my colleague, Professor Stella Shikhnova, who will greet you and say a few nice words to us.
Thank you, dear participants, this important conference, dear colleagues, dear friends. Today in Kiev we have beautiful sunny morning and without air raid alert yet. And it gives me great pleasure to welcome you all on behalf of scientists of the National Academy of Science of Ukraine, Geological Earth Science Department. And at the time of bloody war, time of defense of our independence, the development of scientific and technical potential, especially through such events, it is a very important task. And I think that one of the aim of this conference is to support developing geological and engineering science in Ukraine, promote scientific contact, discussion on geological and anthropogenic processes and hazards, monitoring. Hostilities inflict heavy losses not only for people, on infrastructure, on industrial objects, but also on the environment, including pollution of air, soil, underground water, disturbance of landslide, agricultural land, damage of flora, fauna, and geological environment and geological landmark. And despite the existence of several important legal instruments for environment protection, the environment remains a silent victim and casualty of armed conflict all over the world, and monitoring is in a broad sense, I mean, is one of the most important tools for obtaining reliable information for environmental protection and in our future life also. And this is why I see the relevance of our 17th International Conference on Monitoring. In my opinion, also, the uniqueness of our conference lies in the involvement of researchers from different areas of the geosciences. Also, these events gave the opportunity postgraduate young scientists, young researchers, opportunity to attend the conference, present paper, discuss research results. And I wish all of us, the conference participants, successfully share and expand our basic and applied knowledge in the field of monitoring, to promote networking cooperation between academic and research players in this field, and find maybe new colleagues and spend professional contact. I would like to thank all organizers this conference, and first of all, European Association of Geoscience and Engineers president, who gives such an interesting talk, geological faculty dean Sergei Vyzhva, for creating and supporting this platform for fruitful cooperation, and I wish all of us good health and successful work at the conference. And of course, I also would like to thank the heroic armed forces of Ukraine for the opportunity to hold this conference in the name of peace and development. Slava Ukraini!
Героям слава.
Героям слава. Дякуємо, Стелла. Thank you, Professor Shikhnova. Dear colleague, in 11 we start our plenary section. We have 4 very interesting reports, and we have few minutes, and I give the floor to Dmitry Bozhezha, who will say a few words to you. Please, about our works in today, tomorrow, and after tomorrow.
Thank you, Sergei Andreevich, for your hearing. I just want to share some statistic about our event and some information how we will work in the next days. Totally, I want to let you know that we have very big number of submitted papers, more than 250. We accept for technical program 209 technical presentations that will be split into 3, which was announcement for 10 different topics. Now we have registration for our Zoom events, more than 350 people, and I'm very proud that now during the opening, it's more than 100 people in our virtual hall. Also, I'm very glad that among our presenter, we have the youngest presenter, it's only 18 years, and the oldest presenter, 91 years old. Good professional, Igor Ivановich Rakityansky. Here you can see all topics that we choose for this conference, and as underlined Edward, all of them is very important for near surface community of EGE, and especially for all Ukrainian specialists. And we can see by the submitting activity in papers and desire to participate in our event. And this year, as also we see by the submitted paper, we extend the scientific program with new additional topic. It's monitoring, fixation, and assessing the impact of the war. We have about 9 topics in the separate session, but also it's much more. I think that the papers that connected with such a problem, more than 20 during all the conference, but they will be announcement in the different sessions. I want to thank everybody to participate for this conference, and want to note that for all Ukrainian participants, it's absolutely free of registration fee. But all our work, we will be very grateful if you will make some donation to EGE, Ukrainian Professional Development Fund. You can see the QR code. You can find this information on our website and on the site of EGE. Also, I want to share you information that now we will start the plenary session, and 2 of our presentation will be dedicated to the war problem. It's the first from Natalia Luta about Kakhovka hydroelectric power station, and also the second presentation of Dr. Ksenia Bondar about detecting war-related pollution of soils using magnetic and geochemical methods. We will start the plenary session just in 3 minutes. And a couple of words about our portal for conference. You can start working here. You can see all sessions during the 4 days. Find the way how to go to the different halls. For example, our dedicated session for monitoring, fixation, and assessing of impact of war will take place on the November 10, it's a Friday. It will start after the lunch in Hall 2. And other, you can find the ways that you can go to the Hall 3, study the program, study the all abstracts for the presentations. Please use this functional to find a lot of interesting information, prepare to ask authors for questions. Now I'm very great that we have 107 participants during opening ceremony, and now I think that we can go to the plenary session to start this. I'm very thankful to all our special guests, Edward Sviarda, Stella Shikhunova, for your participation and kind, good words about our situation. Thank you, everybody. And now I want to ask everybody to turn on your web cameras, and I will try to make some screenshot about the number of our participants. Please do it now. And I will do some screenshots that will be published on our website. Now I see only we have the 5-page of all participants. Please turn on your cameras. Just a minute. I want to say that I'm very surprised that we never have such big presence during the opening ceremony, and I hope that all our virtual halls will be such filled with professionals. Okay, thank you. I finished. I wish to
Thank
everybody
you.
good
Thank you,
day.
Dmitry. Thank you, Dmitry. And we can start our plenary section. Now I give the floor to Natalia Luta for our first presentation. Natalia, please, we have 20 minutes to report and 10 minutes to questions. Так. Є у нас Наталя?
Так, я є. Чи
Розширюйте.
видно мій екран?
Не бачимо. Розшарюйте, там є
Екран.
демонстрація екрана. Натисніть.
Натиснула. Share screen.
Так. Поки що не бачимо. Вас бачимо, екрана не бачимо.
Мгм.
Може перейдіть, може у вас декілька вкладок.
Ой, Господи. У мене відкрито, як було в навчанні. Може,
Так.
тоді запустіть мою презентацію, я потім відповім на запитання, якщо можна.
Дмитро, ми можемо запустити презентацію, так, якщо вона є.
Є.
Так, вона є. Зараз вона відкривається. Sorry, everybody, for small technical issues with presenter. We now will start the pre-recorded presentation of Dr. Natalia Luta. It's very huge, so we need 20 seconds to open.
Так, і наступні хай готуються. Ксенія, ви готові до вашої презентації?
Good day, I am Natalia Luta, and the subject of my report is the way to improve water supply to the population of the territories adversely affected by the Kakhovka hydroelectric power station dam explosion. First of all, a few words on the Kakhovka Dam and the experience of similar disasters in Ukraine and world. The Kakhovka Reservoir was created in 1956 by construction of the Kakhovka Dam. The Kakhovka Reservoir is one of 6 larger reservoirs in the Cascade on the Dnipro River. It is located in Zaporizhzhia, Dnipropetrovska, and Khersonska regions. 3 canals, Kakhovsky, North Crimean, and Dnipro-Kryvyi Rih, begins from the reservoir. The Russian occupiers mined the hydroelectric power station on the first day of the invasion of Ukraine and blew it on June 6, 2023. The explosion of the Kakhovka hydropower station dam led to a catastrophe caused by flooding of large areas, human casualties, loss of unique ecosystems, environmental pollution, and huge losses. Up to 700,000 people were deprived of proper access to drinking water. Currently, it is impossible to definitely assess the consequences of this event due to the lack of information from the left bank part not controlled by Ukraine. It should be noted that dams are potentially hazardous hydrotechnical construction, and their destruction can occur as a result of both natural and anthropogenic factors. The largest in terms of human losses and economic damage is the hydrodynamic accident in the Wanzhou Dam, People's Republic of China, in 1975. That accident was caused by a powerful typhoon Nina and flood. 7 provinces were flooded. The official death toll was 26,000 people, but many more died from epidemics associated with the consequences of the flooding, up to 230,000 people. Kakhovka is not the first time that Ukraine has suffered a disaster caused by a hydrodynamic accident as a result of a terrorist attack. On August 1941, after German troops broke through near Zaporizhzhia, NKVD officers blew up the Dnipro Dam. This did not prevent the advance of the Nazi army, but the casualties among the Soviet military and civilians, according to various sources, ranged from 20 to 120,000 people. After the explosion of the Kakhovka Dam, 4 regions, Khersonska, Zaporizhzhia, Mykolaiivska, and Dnipropetrovska, were in the disaster zone and under the threat of dangerous situation related to the quantity and quality of drinking water. Given the high air and water temperatures and very low percentage of canalized rural settlements, an outbreak of epidemics was expected, such as it was in China in 1975. Fortunately, timely measures taken to provide the population with imported water helped to avoid the worst-case scenario in the territory controlled by Ukraine. The disaster has exacerbated the already urgent problem of water supply in the southern regions of Ukraine, especially if the water supply is based on a single unprotected source. We have all seen these long lines for imported water. Unfortunately, the population is not currently being transferred to groundwater. Recently, a decision was made to build a free-water pipeline to provide the several affected cities with surface water. We can only hope that this decision is due to martial law and that after the war is over, the issue of ensuring the optimal ratio of surface to groundwater in the water supply of population will finally be resolved. What should this ratio be? Here we see on the chart the share of ground and surface water in the public water supply of Europe. In European countries, the share of surface and groundwater in water supply differs significantly. This share is determined by the quantity and quality of natural water resources and anthropogenic pressure. Taking into account the condition of Ukraine, this ratio should be at least 50-50. However, in general, groundwater production in Ukraine is about 25% and is constantly decreasing. In recent years, the average annual production of drinking groundwater in Ukraine has not exceeded 5% of the total forecast groundwater resources and 10% of the total proven operational reserves. During the last 20 years, the total groundwater production decreased threefold. And during 2010-2020, it halved. And briefly on the hydrogeological condition of the territory. The affected area is located within the hydrogeological regions of the Ukrainian Shield and the Black Sea Artesian Basin. It belongs to the zone of insufficient moisture. The principal aquifers are found in Cenozoic sedimentary rocks and Precambrian crystalline rocks. As a result of the catastrophic decline of water level in the Kakhovka Reservoir, which until recently served as a source of recharge for Neogene sediment aquifer on the left bank of the Dnipro, the groundwater level will decline. Such unstable regime can lead to the activation of geochemical processes in the zone of aeration and deterioration of groundwater quality. This necessitates the organization of groundwater monitoring in this area. As for forecast groundwater resources, the forecast groundwater resources of these regions vary greatly. They are the largest in Khersonska regions, about 5,000 meters cubic per day, and the smallest in Mykolaiivska regions, only 442,000 cubic meters per day. At the same time, in the most water-rich Khersonska regions, extraction is minimal, only 2%, while in the other regions it ranges from 5 to 8% of the forecast resources. Operational reserves. The operational reserves of groundwater of these regions also very significantly. Thus, in Khersonska region, they are 931,000 cubic meters per day, and in Mykolaiv regions, only 103,000 cubic meters per day. Below is the information of state enterprise joint form of Ukraine on the number of explored sites of drinking and industrial groundwater deposits and dynamics of changes in extraction of groundwater operational reserves for drinking and industrial purposes for 2016-2020. We see that in the Mykolaiv region, water extraction has been consistently low in recent years and was carried out at 13 operational sites. In the Dnipropetrovsk region, water extraction also has been consistently low and was carried out at 6 or 7 operational sites. In the Porizhka region, water extraction was larger and has been growing slightly in recent years. And in Khersonska region, it is the richest in groundwater resources region among these 4 regions. However, we see a downward trend in groundwater extraction. This is the table with summary data on forecast resources, operational reserves, extraction, conclusions. As the war experience has shown, water supply system using only surface water is in critical condition is imperfect. The changes in the recharge condition of shallow aquifers in the area of the drained Kakhovka reservoir may lead to a deterioration in groundwater quality. This necessitates the resumption of monitoring, especially since groundwater is the most important source of water supply. Dnipropetrovska, Zaporizhzhia, Mykolaiv, and Khersonska regions have sufficient unused operational reserves of drinking groundwater, which makes it possible to expand water supply from pollution-protected, already explored sources. But the distribution of operational reserves across the regions is extremely uneven. In particular, in the north, within the Ukrainian Shield, groundwater has not been assessed in previous years due to its high salinity and very complicated hydrogeological conditions. Modern water treatment technologies make it possible to expand the region's water resource base. Transferring the population's water supply to groundwater requires exploration of deposits in certain areas, construction of water pipeline, and water treatment to improve its quality. As the experience of other countries shows, effective solutions of this problem requires government intervention for development, implementation, and financing of relevant state programs. Thank you for attention.
Thank you for Natalia. Thank you and Dmitro for your presentation. And now question. Have you question?
У мене коментар, вибачте, там просто the last slide you didn't see. На останніх слайдах там була інформація про якість. Справа в тому, що досить непогана якість, як для півдня України, на багатьох водозаборах, особливо Херсонської області, що особливо робить привабливим цю ідею про відновлення повноцінного водопостачання багатьох населених пунктів за рахунок підземних вод.
Thank you. I have one question, Natalia. What about radioactive isotope pollution in this soil and after destruction Каховська ГЕС?
Якщо дозволите, я українською відповім на це запитання. Ну, зрозуміло, що, безумовно, там є певна частка радіоактивних елементів, але, як дослідження показали, все-таки основна частина накопичена у межах Київського водосховища. Звісно, це стосується не лише радіоактивного забруднення. У донних відкладах цього водосховища завжди в донних накопичуються забрудники, полютанти і важкі метали, і радіонукліди. І те, що сталося, безумовно, воно сколихнуло всю цю масу і вона поплила в напрямку моря. Все це дуже є недоброю ситуацією. Ну, я думаю, що поступово воно буде якимось чином відновлювати. Ну і тут мені здається, що ще у цьому контексті варто було б обговорити тему про доцільність відновлення дамби і моря як такого. От мені здається, що це зараз така тема болюча, тому що багато є з цього приводу різних думок, різних пропозицій, таких волюнтаристських, будемо казати. От тут би повинне бути таке зважене спільне рішення з цього приводу, тому що, звісно, можна було також приводити річку до первісного стану, але робити це поступово, без от таких катаклізмів. Зокрема, про один з негативних наслідків ви згадали, оці забруднені донні відклади.
Ясно. Так, дякую.
Can I also ask a question?
От, please, Ксенія.
Пані Наталія, could you please tell us, in case the dam will be reconstructed, how much time will it take to restore the water regime which was before the catastrophe?
You mean reconstruction of the dam, of the Kakhovka Sea, or its natural status? What do you mean?
Якщо дамбу відновлять, скільки часу піде на відновлення водного режиму, який був
як
раніше?
на мене, ну тут я ж кажу, що тут якраз оце питання найцікавіше. Мені здається, що тут повинні всі фахівці взяти участь. Як на мене, особливого резону її відновлення немає. Зараз Дніпро повернувся в своє русло природнє. Власне, якщо порівняти оці карти до початку затоплення і теперішній стан, власне, Дніпро у своєму руслі. Значить, тут треба, щоб була думка така компетентна фахівців з різних галузей, тому що з точки зору енергетики не дуже ефективним цей об'єкт був, прямо кажучи. Не дуже. Найменш ефективний з-поміж усіх, значить, енергетичних об'єктів, зведених на Дніпрі. З точки зору сільського господарства, таке питання, таку проблему можна вирішити за рахунок каналів, не обов'язково затоплювати величезні території. Як на мене, я б за те, щоб все-таки не затоплювати, а відновити Великий Луг, цю історичну територію українську, і, значить, можливо, змінити землеробство, можливо, там якісь випасні робити такі господарства тваринницькі. Ну, тобто є різні варіанти, але, як на мене, я ж кажу, що це не повинно бути якесь волюнтаристське рішення, це рішення повинно бути зважене. А скільки часу буде потрібно? Ну, я думаю, що не надто багато часу, але, як на мене, це буде третя за ліком катастрофа. Спочатку затопили, була катастрофа, потім осушили, була катастрофа, а тепер знову буде чергова катастрофа. Я не бачу в цьому сенсу, особисто я.
Ясно, дякую. Прошу ще запитання, колеги.
If I can have a question.
Please.
If you are looking for the future development, you see this part of water was used for supplement the Crimea Peninsula. So in next maybe 10, 20 years, how we are going to solve this question, water supply of Crimea Peninsula? Because someday this territory is going to be a part of Ukraine.
I think that the question of water supply of Crimean Peninsula should be solved after the occupation, and now it's a problem of occupiers.
It's a part of our mission as a scientist to look forward.
In Crimean Peninsula, there are sufficient resources of groundwater for drinking purposes of population. As for other purposes, it may be a problem.
We can use maybe some seawater for technical
Seawater for technical purposes, and there are a lot of water intakes of deposits of groundwater in Jurassic sediments in mountain Crimean and Neogene aquifers within the steppe part of Crimean Peninsula. So I already said it's enough resources for drinking.
Okay, thank you.
Thank you. Thank you for Natalia. And the other questions, colleague, please maybe discuss about this problem. Yes. Так, Наталя, давно питання вирішувалося з приводу взагалі існування каскаду ГЕС на каскаду цих водосховищ на Дніпрі. І воно було дискусійне багато років. Ну, зараз от Каховська, добре, а що ж робимо з іншим водосховищем? Як ви з цього приводу? І чи варто з ними щось робити?
Ну, ви знаєте, тут питання складне, я ж кажу, тут навіть, бачите, є інші думки у шановних колег. Хтось вважає, що потрібно відновити це водосховище. Річ у тім, що в Європі зараз існує низка програм, присвячених якраз відновленню хоча б принаймні частини річок, повернення їх до їхнього первісного стану. Тому, звісно, тут дуже погано, як це сталося. Що це катастрофа, це однозначно. Те, що загинули люди, загинули тварини, деякі червонокнижні. Але вже те, що сталося, звісно, його треба було вирішувати поступово знижувати, спускати, поступово заліснювати. Щодо інших частин, інші водосховища, інші греблі, інші енергетичні об'єкти, вони, будемо казати, мабуть, більш ефективні. Тому тут треба зважувати думку і енергетиків, і гідрологів, і геологів, і біологів, і аграріїв. Це повинна бути думка компетентна, провідних експертів. Це, знову ж таки, не повинно бути, чи є таке рішення на рівні хочу, не хочу. А те, що в Європі відновлюють хоча б частково річки, так, така тенденція є, і я вважаю, що нам також треба, раз ми туди зібралися, слідувати цій тенденції.
Ясно, дякую. Thank you. Колеги,
Одне питання.
прошу, да. Валентин.
Скажіть, будь ласка, територія, вода звільнила величезні території, так, які були затоплені. А як з точки зору вивченості фізичної, геологічної цієї території, є потреба її довивчити, чи є там якісь перспективи на, я знаю, називаємо так, корисні копалини?
Ні, безперечно, там те, що треба вивчати, це однозначно. По-перше, треба вивчати у тому контексті, що змінилися ж умови кардинально. Я про це говорила, але в такій короткій доповіді дуже важко висвітлити всі аспекти. Звичайно, там є об'єкти і родовища, і археологічні безцінні об'єкти, і багато там чого зараз вийшло на поверхню. Але нас, як гідрогеологів, найбільше цікавить те, що змінилися умови живлення. Коли створили це водосховище, воно ж стало великим осередком живлення вище залягаючих водоносних горизонтів. Якщо у нас розвантажуються зазвичай ці горизонти у річку, то тут навпаки почалося. Ну і звісно, тепер, коли після стількох років у нас відбувається зміна, у нас область живлення стала областю розвантаження, то звісно ми можемо очікувати зміни хімічних характеристик води. По-перше, там вже зона континентального засолення, тобто там ґрунти засолені, і ми можемо очікувати також впродовж певного часу зміну хімічного складу цих водоносних горизонтів, тому що там оця техногенно змінена вже нами зона аерації, вона там окиснювані умови зміняться, тобто відновлювальні, окиснювані, тобто те, що там треба проводити дослідження, це однозначно, як еколого-геологічного спрямування, так, звісно, і геологічні, і біологічні, і весь комплекс.
Так, thank you, Natalia. We need to start next our presentation, and now I give the floor to Ksenia Bondar for next presentation. Ksenia, please.
Thank you very much. Now I share my screen. Could you see my presentation?
Yes, we see.
Okay. It's my pleasure to present this work on this conference, annual EEG conference. I only regret that I cannot do it personally in Kyiv, because currently I'm an assistant professor in the Institute of Geophysics in Polish Academy of Sciences, but also affiliated with the Institute of Geology of Taras Shevchenko, National University of Kyiv. And the first results, which I'd like to show you now, are related to the new project, which is on the very starting stage, international project titled Quantification Magnetic Properties of Soils to Evaluate Sustainable Hazards from Heavy Metal Pollution due to military activities in Ukraine. This project is implemented within the framework of long-term program to support Ukrainian research teams at the Polish Academy of Sciences, carried out in collaboration with US National Academy of Sciences, with the support of external partners. As part of effort to build and sustain a healthy science and research ecosystem in Ukraine, 18 grants were awarded to facilitate the pursuit of research projects by teams of Ukrainian researchers and scientists hosted by the institutes of the Polish Academy of Sciences. This project is focused on quantitative assessment of soil pollution with heavy metals due to military-related activities through in situ and laboratory measurements of soil magnetic properties and establishing their links with heavy metal contents. Recently, magnetic measurements have been increasingly used as a tool for the detection of heavy metal contamination in soils and sediments caused by anthropogenic emissions. The magnetic enhancement observed in the vicinity of steel mills, power plants in the cities is caused by airborne particles from traffic and industrial influx. Aerosols and dusts of anthropogenic origin contain different magnetic phases, such as magnetite, magnemite, and metallic iron that accompany toxic heavy metals like lead, nickel, cobalt, chromium, titanium, cadmium, zinc, and mercury. All of them have negative effect for living organisms. Positive correlation between magnetic susceptibility and heavy metals contents have been observed in soils and dust from industrial areas. So combined stepwise magnetic geochemical approach is proved to be the most efficient way to outline soil pollutions with heavy metals. What we propose in our project, we propose to use the magnetic method as a tool for quantification of soil pollution with military-related heavy metal emissions. Environmental contamination with chromium, copper, zinc, lead, and cadmium has been reported in areas of battlefields, artillery ranges, and granite quartz. Heavy metal emissions were shown to be dependent on the type of ammunition. Large areas in Ukraine undergo missile attacks and artillery shelling. As massive strikes and large ground invasion were launched, Russian forces constantly bombed both military and civilian targets in the front line and far from it. And weapon residues and small size particulate matter in Ukrainian cities, rural areas, and agricultural lands are sources of lead, copper, and other heavy metals. Metals translocate to water, thus increasing the risks of human exposure. So the goal of our project is to elaborate a novel strategy for the assessment of military-related soil pollution based on combination of magnetic and geochemical methods and represented in geoinformation models of polluted regions. What we plan to do, the action plan include in situ magnetometer surveys and magnetic susceptibility mapping, soil sampling, and of course laboratory magnetic and geochemical measurements. Polluted soils and soils deposited soils and surface deposits will be studied comparatively to unpolluted ones. Field measurements and sampling will be performed within two types of test sites. First, our agricultural lands and at the recaptured regions used to be massively shelled, like outskirts of Balaklia town in Kharkov region, outskirts of Borodyanka town in Kiev region, and others. And the second localities will be cities experienced numerous artillery attacks like Kharkiv, Chernihiv, Zaporizhia, Mykolaiv. As a project team, we collaborate with different organizations, including central and local public administration bodies, militaries, rescuers, academic and non-governmental research institutions. At the very first stage of the project, Kiev region was in the focus of our activity. And here we represent first results of field measurements and sampling performed within unexploded ordnance landfill site in Kiev region and Ozera battlefield at the recaptured area of Kiev region. Both studying areas are located in the forest zone of Ukraine. This soil was identified as Umbric Albeluvi soil abruptic according to WRB FAO classification. Field measurements included high-resolution magnetometer survey using optically pumped instruments and magnetic susceptibility mapping using handheld devices. Additional laboratory measurements were carried out in the Institute of Geophysics of Polish Academy of Sciences and in the Demidov Paleomagnetic Laboratory of the Institute of Geophysics of National Academy of Sciences of Ukraine. Results from UXO landfill site. The magnetic susceptibility of soils at the UXO landfill site, which has been operating for the last 10 years, demonstrate decreased as moving away from an explosive crater. This decrease is sharp when we measure bulk material in situ, and more gradual when material is sifted through a 1 millimeter mesh sieve. You can see the graph on the screen. So following an explosion event, the distribution of susceptibility in soil may show distinct patterns depending on the distance from the crater. susceptibility of soil closer to the equator may exhibit higher values due to the deposition of fragmented material containing magnetic minerals and metallic iron, of course. This is because the explosion's force and subsequent ejecta can distribute magnetic particles over a relatively small region near the crater. Example of this particular landfill site shows susceptibility drop down to the background value at the distance of over more than 25 meters. Additionally, weathering processes such as erosion and transportation can further disperse the soil and mix it with material lacking magnetic minerals, leading to reduced magnetic susceptibility. The observed magnetic enhancement is related to changes in magnetic mineralogy comparing to background soils. Magnetic mineralogy was assumed from Curie temperatures and phase transformation observed during measurements of the thermal dependence of the magnetic susceptibility when heating the samples from the room temperature to 700 degrees. These experiments show that samples from the polluted area demonstrate additional peak on the susceptibility temperature curve, probably related to pyrrhotite transformation from monoclinic to hexagonal form, while the other distant soil demonstrate the typical natural behavior. This is the evidence of the presence of iron sulfide derived from explosion emissions. Detailed studies and measurements can provide more specific insight into the horizontal distribution of magnetic material with respect to the distance from an explosive crater in a particular context. These are some examples from Ozera battlefield. Explosive weapon impact craters and unexploded ordnance are particularly relevant near the former battlefields. The results of magnetometer survey can be used to delineate potentially contaminated sites. At the site 1, we can see 3 craters. Craters 1 and 3 have diameter up to 3 meters and the maximum depth of 0.5 meters. They are caused by heating with GRAD multiple launch rocket system. Irregularly distributed shrapnel and the resulting noise in the magnetograms are present on the impact places. And crater 2, the biggest one, has diameter of 6 meters, maximum depth of 1.7 meter, and sharp slopes in sandy soil. This is there is no disrupted material around the crater too. The related magnetic anomaly reaches 800 nanotesla, having negative part at the southeast. It could contain UXO, thus posing the continued threat to safety. At this site too, we observed the anomaly probably related to thermoremanent behavior of the heating soil material. This anomaly has negative part at the north. The maximum intensity was 127 nanotesla. Susceptibility was measured on hundreds of soil samples collected in explosive craters and around. However, more statistically approved information is needed to quantify the effect related to a single explosion. By now, we didn't succeed in this. So military-related pollution in soils is linked to iron debris clusters and can be detected using magnetometer and magnetic susceptibility surveys. Due to Russian invasion in Ukraine, there are a lot of agricultural lands which have been undergone massive artillery shelling. And being cleaned from UXO, they retain a lot of weapon pieces and particulate matter, which are constant sources of heavy metals and other pollutants. A quick and reliable assessment of the pollution level is needed to develop specific strategies for the restoration of affected territories, both from the point of view of further living there and of their effective use for the agriculture, which in turn is an important factor in the food security of the whole world. We hope the novel soil pollution assessment methodology will facilitate the development of economic and social measures by the Ukrainian and international decision makers. We believe that application of the results to the environmental pollution assessment, military hazard evaluation, and quantification of soil degradation will accelerate the development of Ukraine's post-war recovery strategy. Thank you for your attention. This is our team volunteers. Thank you.
Так, ясно. Що? Так, thank you. Так, зараз секунду. Десь у мене з'явилося. Так, десь у мене віконце Zoom пропало.
Сергій Андрійович, ми вас бачимо, чуємо.
Ясно. У мене віконце пропало. Thank you, Ksenia. Very interesting presentation. Colleague, please, questions. I have one question. What about other geophysical method for investigation the military pollution?
By now, we are only focused on magnetic methods, both in the field and in the laboratory. In the field, now we do magnetic surveys, high-resolution magnetic surveys using optically pumped magnetometers. And we also collaborate with some non-governmental organizations, helping them to develop the drone-based magnetometer technology for UXO detection. Considering other methods, yes, we would like to apply other methods in case they will be relevant to our purposes of our project.
Thank you. And Ksenia, your team many years studied the heavy metal pollution in many cities in Ukraine. Is it important for this investigation?
Yes, this is very important, and I am very glad that this material now could be used as to characterize background situation which was in Ukrainian cities. For 5 last years, we collected soils and also measured air filters from 20 cities in Ukraine, including those which are now in the frontline zone. And now we have a possibility to compare what changes occur due to war. Thank you.
Thank you. And we have any stationary points for investigation air pollution and other. Have you information about anthropic pollution with war, about this problem?
On this topic, we collaborate with the geophysical observatory named after Boris Srizhnevsky, and probably in near future we will be ready to introduce some report on this topic.
Thank you. Colleague, please question for this presentation.
Можна запитання?
Прошу, Стелла Борисівна. Це Наталія. Прошу, будь ласка, включайте мікрофон.
Так. Скажіть, будь ласка, чи ви оцінювали можливий негативний вплив ось такої, власне, наслідків воєнної діяльності в різних ландшафтно-геохімічних умовах? Наприклад, Київщина, там Поліська зона і степова зона. Наскільки буде потім активною міграція цих компонентів?
Okay, maybe I also answer in Ukrainian. Так, ми почали наш проєкт на дуже початковій стадії, що знаходиться, і ми почали з Київщини. В умовах цих піщаних ґрунтів, що відбувається, як накопичуються ці забрудники в піщаних ґрунтах. З одного боку, ці ґрунти є дуже сприятливими для наших цілей, оскільки вони мають дуже низький власний магнетизм і низький вміст важких металів так само. І на цьому тлі буде простіше відрізнити оцей вплив від вибухів, від скажімо так, військової діяльності. Але в наших планах також дослідження в Харківській області. На жаль, ми можемо тільки планувати якісь роботи в регіонах, які були деокуповані. І там ми очікуємо більш складну ситуацію, оскільки ґрунт чорноземний має високий вміст власних ферромагнетиків, власних важких металів. Так що ці виклики ще у нас попереду. Дякую.
Дякую.
Так, есть. Так, we have 9 minutes and maybe discuss about this problem and other simple problem. Ксеня, будь ласка, трошки більше розкажіть про інші проекти, можливо, ви знаєте, які по цій програмі були виграні, і чим планують колеги займатися, і наскільки, які пріоритети були?
Ця програма покриває 18 проєктів в різних галузях. Починаючи від медицини, закінчуючи якимись гуманітарними науками. І всі команди працюють в Україні, керівники працюють в Польщі. Дуже-дуже різні проєкти. Я бачу питання від Сокольчука Константина.
Будь ласка, Костянтин.
Так, дякую вам. Моє запитання частково пов'язане з попереднім, відповідь на попереднє. Ви сказали про те, що буде складніше працювати з коли будуть чорноземні ґрунти. А як щодо територій, які мають значне, наприклад, індустріальне забруднення, тобто на яких була значна частина пилу від фабрики подібного плану. Чи ви розглядали вже подібні якісь моделі, які будуть похибки в таких ситуаціях? Чи можна буде застосовувати ці методи для дослідження навколиць міст, наприклад, в тій же Донецькій області, де можуть бути такі ситуації, особливо поруч з шахтами? Особливо, якщо стосується, ви казали, що перед наступних етапах може бути застосування дронів, особливо в контексті цього мені було б цікаво. Тобто, наскільки це надійний метод буде в цих умовах?
Дякую. Саме така ситуація складається в багатьох наших індустріальних містах, які зараз страждають від обстрілів. Ну, зокрема, Запоріжжя. Ми зараз працюємо з матеріалами, з ґрунтами і фільтрами, і іншими матеріалами з Запоріжжя. Намагаємося встановити оцей довоєнний рівень вмісту феромагнетиків, вмісту важких металів, їх розподіли, щоб потім було з чим порівнювати, коли ми зробимо, я сподіваюся, нові відбори за тими самими схемами, як були зроблені довоєнні. Ну, зокрема, для міст з високою промисловою активністю можна очікувати її зниження, і ну, цього теж не можна виключати, що в повоєнних зразках ми отримуємо не обов'язково підвищення вмісту важких металів і збільшення магнетизму, а навпаки зменшення, що буде віддзеркаленням просто зниження промислової активності. Ну, можливо, за якийсь час я зможу вам більше розказати з цього приводу. Дякую.
Ясно. Дякую, Ксенія, за питання. Тоді в нас ще є трошки часу, декілька тоді запитань. Вводили, я пам'ятаю, у ваших роботах вводилось таке поняття, як індекс забруднень, яке включало в себе там спільну дію декількох видів, умовно кажучи, важких металів, там інших речовин і так далі. Чи ви плануєте переглянути, можливо, якісь нові ввести критерії щодо оцінки тієї чи іншої території? Це одна частина питання. А друге, вам все одно треба порівнювати з якимись чистими територіями, рекреаційними. Чи не плануєте ви використовувати дані не тільки по території України, а можливо і в тій самій Польщі, раз ви там працюєте зараз, або можливо якісь інші ділянки? Дякую.
Ну, щодо індексів забруднення, то вони введені не нами, ми просто використовуємо ті індекси, які загально прийняті для оцінки геохімічного забруднення територій. А стосовно порівняння з чистими регіонами, то так. Завжди потрібно мати фонове значення, щоб оцінити щоб кількісно оцінити забруднення, завжди ми повинні мати фонові значення. Для сільськогосподарських територій ці значення будуть отримані на тих самих типах ґрунтів, але які не підлягали військовому впливу, а для міст ці значення будуть отримані з тих колекцій ґрунтових, які ми маємо, які були відібрані перед війною в довоєнні роки. Дякую.
Could I add one point?
Yes,
One
please.
thing. After conversation with some military representatives and colleagues of geochemistry, actually we don't know exactly what Russians put inside missiles, what components. Sometimes we don't know this, so this could be not only well-known heavy metals for us. Possibly this could be some materials unknown for us. And the challenge is if we could detect it. Possibly after our studies, after our projects, we will answer this question. I don't know for now. Thank you.
Thank you.
I don't know, Sergey Andreevich is talking something or not, because
Sorry. Я сказав, що Олександр доповнив виступ Ксенії, так? І так як в нас залишається менше 1 хвилини, ми можемо готуватися вже до наступного нашого виступу. І now I give the floor to Dr. Олександра Верпаховська for our next presentation. Please, Alexander.
Just.
Так. Ми поки що нічого. Уже бачимо.
Here, yes?
There is.
Окей.
Так, запускайте презентацію, щоб
Так.
ваш екран.
Так. Here, yes? І see.
Yes.
Okay. Thank you for the invitation to the plenary section. I'm Alexandra Verpakhovska. I'm head of the department, the regional problems of geophysics of the Institute of Geophysics of the National Academy of Sciences of Ukraine. And now I'd like to present you the results of our research, seismic image of the upper crust on the Rom-Eucharsis profile across the Ukrainian Carpathians from the migration method. The main purpose of our research were to study the structure of the upper crust, about 30 kilometers of the Ukrainian Carpathians, according to the regional seismic profile, Rom-Eucharsis, which passes from the Apuseni Mountains in Romania to the western part to the Ukrainian Shield, and show that a seismic image of the upper crust structure obtained using finite difference reflection, refraction, migration allows us to obtain additional useful information for the interpretation of regional seismic data observed by wide-angle reflection, refraction method. The Institute of Geophysics has been participating in international projects for many years, together with colleagues from different countries. And due to these projects, seismic work were carried out along a number of regional profiles in Ukraine. This map shows the position of these profiles. One of them is the Rom-Eucharsis profile. On the slide, we can see the tectonic setting of the Rom-Eucharsis area. The Rom-Eucharsis profile passes from the Apuseni through the Transylvanian Basin, Eastern Carpathian, and through the Eastern Carpathian Scraton to Ukrainian Shield. This is the second of the wide-angle reflection refraction profile was crossed the Ukrainian Carpathians. The first profile was pancake. Both profiles were performed to study the Ukrainian Carpathians and Ukrainian part of the Carpathians trough. These are the geophysical data obtained by different geophysical methods along the Rom-Eucharsis profile. The main tectonic units crossed by Röhm-Eucler-Sayce profile corresponds gravity and magnetic patterns. The main feature of the gravity field is the strong negative anomaly associated with the Carpathian belt and its 4D. The surface heat flow map, a low panel, shows high values in the Carpathian associated in a Carpathian associated with young tectonics and magmatic activity on Neogen age. Observation system of the wide angle reflection refraction method have a number a difference from the standard reflected wave method. The main of them are irregular steps between both for receiver and sources, as well as large offsets reaching several hundred kilometers. At these distances, many standard seismic processing techniques will not be very effective because they focus on reflected waves. And reflected waves are recorded in limited intervals of offsets from the source. In this case, it is necessary to include in the processing refracted waves, which are well recorded in the first arrivals at large offsets. On the slide, we can see some seismic shot gathers observed along Röhm-Eucler-Sayce profile. The wave fields demonstrate the types of main types of seismic phases that were used for migration. These are PG, refracted from the basement and upper crust, PN, refracted from Mocha, and PNP, reflected from Mocha. The standard result of processing wide angle reflection refraction data is a velocity model calculated by the ray tracing method. The ray tracing method was applied to the Röhm-Eucler-Sayce regional profile data. And on the slide, we can see the velocity model calculated for this profile. But the ray tracing method only uses the kinematic characteristics of the wave fields. At the same time, the inclusion of the dynamic characteristics in the processing will allow us to obtain to extract the more information about structure, geological structure. Seismic migration is a seismic data processing procedure that allows us to obtain a picture of the depth section based on the dynamic characteristics of the observed wave field. The Institute of Geophysics has been developing finite difference methods for migration and wave field modeling for a long time. One of them is a finite difference migration of reflected and refracted waves. The method was proposed by Vitaly Nikolaevich Pilipenko in 1980, and the method itself, as well as methodology for its application for wide angle reflection refraction data processing, for many years was developed. To date, this is the only migration method that has shown its effectiveness in processing wide angle refraction data observed in different regions of the world. On the slide, we can see a comparison of the principles of the imaging, the standard reflection migration, and the reflection refraction migration. In the case of reflection migration, we have only one point where a reflected wave reflection. But in case of refracted wave, we have 2 points where refracted waves intersection of the refractive boundary. This leads to ambiguity in solving the image formation problem. To solve this problem, in our finite difference reflection refraction migration, the source is transferred to the refracting boundary, and the image is formed at the point where the waves exit the refractive line. Thus, the algorithm of finite difference reflection refraction migration consists on preparing the observed waves, moving the source to the refracting boundary by calculating the time of passage of the upper layer, direct continuation of the time field from the moved source by solving the Eikenal equation, reverse continuation of the wave field from the receiver by solving the scalar wave equation, and the condition for image formation is the sampling of the amplitudes of the extended wave fields at moments of the extended time fields which at the moment exit, where refracted wave exit from the refracted line. Thus, the algorithm for finite difference reflection refraction migrations using for wave field for processing wave fields observed along the Rom-Euclides profile. To form the image of the crystalline basement, velocity values were used for sediments from 5.2 to 5.6 kilometers per second, and in the basement 6.3 kilometers per second. On this slide, we can see the result migration image along the Rom-Euclides profile upper image, and its interpretation low section. The migration image of the upper crust made it possible to highlight additional details of its structure. Thus, the migration image shows the TTZ, the Sayre-Tornquist zone, a transition zone between the Craton and Young continental terrains. It's a near vertical seismic boundary located in the pre-Carpathian fault and traced in the upper crust between the Carpathian for deep and the extended southwestern edge of the Craton. The Carpathian prism, up to 20 kilometers deep, shows a three-layer structure like a graben in graben. The slide shows a comparison of the structure of the upper crust according to the Rom-Eucharses profile data obtained using finite difference migration of reflected refracted waves and calculated by the ray tracing method. The similar of both models is the Tisa-Dacia terrain, where the Puseni-Ophiolite complex, crystalline Tisa and Dacia are distinguished, but different configuration and thickness in migration image, that on the velocity model. In general, we can say that the results are similar in general terms, but the migration image shows a slightly different configuration of the structure. On the slide, we can see a comparison of migration images of the Carpathian sedimentary prism according to the Rom-Eucharses and pancake profile. The Ukrainian Carpathians crossed by two wide angle refraction profiled, discussed above Rom-Eucharses profile and previously the pancake line. The image of the crust on the both profile across the Carpathian from the migration method. The migration method allows obtain us the picture of the geological structure of the Carpathian's prism. The seismic image for the Carpathian again shows that its depth about 25 kilometers, and it forms similar on the both images. In conclusion, I would like to say the following. The Rom-Eucharses is the second wide angle reflection-refraction profile crossing the Ukrainian Carpathians that was processed by finite difference reflection-refraction migration method developed at the Institute of Geophysics of the National Academy of Sciences of Ukraine and interpreted. The migration on the Rom-Eucharses profile shows new details of basin architecture and upper crystalline crust structure for the area of accretion and collision of young Tisa Dacia microplate to the East European Craton. The migration image of the basement of Apuseni Mountains and Transylvania Basin on the Rom-Yucca Seas, which crosses the junction area of the Tisa and Dacia terrains, shows the several blocks of different wave images and probably affinity. As shown, the combination of the results of kinematic and dynamic processing of wave fields recorded by the wide angle reflection-refraction method allows us increasing the information for their interpretation. Thank you for attention.
Thank you, Alexandra. Please, question. Так, бачу, Михайло Лубков.
Yes.
Please.
Can I give you a question? What about practical usage of your method and accuracy of your method? Can you, for example, can you find places of oil and gas deposits?
Okay, this is result is wide angle reflection-refraction migration by the wide angle regional profile. As I say, that wide angle reflection-refraction characteristics with characteristics, their large offsets from the source and very large steps between receivers. In this distance, deposits is not detected. It's for reflection migration allows us to detect deposits.
Thank you.
Thank you very much. And the next question, if I can.
Please.
Can you make some decision about your investigation about tectonic situation in this region?
What do you mean?
Скажіть українською, що ви хочете.
About tectonical reasons of this region.
Аня, може ти о тектонике?
Tectonical.
Да. Можно я подключу свою коллегу, которая расскажет больше об этом? Тектоническом. Она соавтор. Давай.
Да.
Будь ласка.
Вітання. Моє прізвище Муровська Ганна. Я також працюю в Інституті геофізики. Я є співавтор цієї доповіді. Ну, як вже сказала Олександра, ми отримали додаткову інформацію порівняно до швидкісної моделі, яка отримана за кінематичними даними за часом першого вступу. Ну, наприклад, коли Олександра показувала, і зараз може показати слайд, де вона порівнює ці дві моделі, то, наприклад, на швидкісній моделі в тій області, де на поверхні розташован Мармарський масив, чи Дакіди, чи внутрішні Карпати, на швидкісній моделі там стоять суцільні знаки питання. А наша, ну, це додаткове наше міграційне зображення, де це у нас там є? Отут, бачите, отут у нас стоять такі знаки питання, не дуже зрозуміло, що знаходиться в цій області. А на міграційному зображенні це така ділянка, яка характеризується прозорістю, тобто відсутністю відображаючих границь, і ми це можемо інтерпретувати, наприклад, як великий масив, ну, якісь магматичні тіла якісь. Така додаткова інформація. Також, от ви бачите, оця зона, яка знаходиться під Трансильванським басейном, і тут вона не є дуже виразною на цьому зображенні. Тут вона у нас як така виглядає, як я б так сказала, що навіть якась така сутурна зона, яку ми можемо вже інтерпретувати як зону членування, ну, Тисі і Дакії. Ну і так далі, і так далі. Тут в межах східноєвропейського кратону, як ви бачите, ми можемо тут виділяти магматичні, якісь, мабуть, гранитні інтрузії, до яких також нечуттєвий метод кінематичний метод. Так що додаткові деталі ми можемо виділяти. Перш за все, це інтрузивні магматичні тіла. І, по-друге, міграційний метод, він більш чуттєвий до вертикальних границь, і тому на нашому міграційному зображенні є більше вертикальних границь. От, наприклад, границі, що такі круті субвертикальні, ми інтерпретуємо їх як розломи, які обмежують те, що ми називаємо карпатський трок чи карпатську призму. Не дуже розуміло, як її називати, але ми бачили, що обмежують оцю карпатську призму з двох боків такі вертикальні розломи. Тобто є додаткові деталі, і якщо інтерпретувати вкупі ці два методи, то ми отримуємо для тектонічної інтерпретації таку цікаву інформацію.
Дуже дякую.
Так, дякуємо. Тепер і співавтору. Так, дівчата, there are many regional profiles in the territory of Ukraine. What makes this profile interesting? Чому саме цей профіль такий цікавий? Так? І питання стоїть, чи застосовували якісь інші методи, крім сейсмічних, саме для вирішення задач структурних таких побудов. Ну і ще одне, у вас там оці магматичні тіла коріння не мають. Як же, звідки ж та інтрузія взялася, коли в неї немає коріння ніякого? Вона що, з космосу туди попала?
Досліджується.
Ви про які магматичні тіла питаєте? Оці чи ці?
Ні, ото і справа, ото, що зараз.
Оце, що зараз поки. Ну, то ж, це, знаєте, це український щит, то може бути просто якесь, так називається, плавління.
Ні, може якісь тріщини є,
Ні, ну,
які не видно на таких великих офсетах.
Ну, от, до речі, я хочу сказати, що зараз ми інтерпретуємо ще один імідж через український щит. І, до речі, у нас дійсно до таких магматичних, ми думаємо, гранітних тіл, ми знаходимо, і, мабуть, і тут вона є, оце така, бачите, така розломна зона, я думаю, оце. Просто ми тут, знаєте, на деталях не дуже фокусувались, бо задача була показати такі більш глобальні основні структури.
Тектонічні
Да, але бачу, я зараз навіть бачу, що тут можна простежити оцей наклонний, крутий розлом. А що ми ще?
Так, ясно.
Насчет этих профилей, да?
Так.
Значить, ГСЗшні профілі, їх дуже багато. На території України, ну, не дуже, хотілося б більше, але достатньо для того, щоб вивчати великі структурні тектонічні одиниці. Тому, мабуть, і за іншими профілями будуть інтерпретаційні моделі побудовані.
А ще ви питали, які інші методи застосовувались, то наші оці профілі ГЕЗ, вони слугують основою для моделювання, тобто структурною основою для гравітаційного і магнітного моделювання, і вже побудована магнітна модель, я знаю по профілю ROMUX-6, і знаю, що будується вже гравітаційна модель.
Так, дякую. Дуже цікаво. Так, у нас залишається менше 1 хвилини.
А можна один коментар?
Прошу, Ігнат Миколайович.
Ситуація така. Останнім часом Микола Якимчук провів серію експериментів, які засвідчили, що сейсмічні матеріали, сейсмічні профілі, побудовані коректно, можна використовувати для частотно-резонансної обробки і наповнювати розріз конкретними породами, в тому числі корисними копалинами, якщо нафта є, чи вуглеводні, вони по сейсмічним розрізам фіксуються. Зацікавленим можу надіслати такі матеріали. Дякую.
Дякую, Ігнат Миколайович. Thank you for presentation. Значить, продовжуємо нашу роботу. And next presentation of our plenary section. Now I give the floor to Mauro De Donatis for
Yes, I'm here.
our next presentation. Please, Mauro.
Okay. So thank you for inviting me. It's an honor to be here. And let's start the presentation. I try to share my screen. Should be this one. Okay. So, not sure. Okay. Can you see the presentation? The first slide?
Yes, I see.
Okay, thank you very much. Okay, I introduce myself a little. I'm from Italy, and I'm working for many years on GIS to bring GIS in the field. And so I would like to share with you the history that we had in Urbino, in our university, what we did in the last few decades about procedures and methods on working with the GIS directly in the field. I'm teaching digital geological mapping and geomatics in this university, and I'm also a founder of a section of Italian Geological Society, of a section called Geoscience and Information Technology. And every year we have a good conference in Italy, and if you can, you are invited to come and join us with your very interesting presentation that I see just this morning. So let's start. I'm trying to get a smile from you. That was a sort of joke in the 90s, where people start to think that the computers could go to the field as well, to work in the field. So after a few years, this is a picture of 2006, I think. There was just a guy. It was a conference in Germany. And there was this guy with a tablet PC working directly in the field. So a few years, there was a big improvement in this field. Let's start from the beginning. So the first, that at least we say that was the first that making a geological map, William Smith from England. but also Charles Darwin around the world make a lot good geological maps. But before of that, in Italy, the Renaissance age, Leonardo da Vinci did something with his codes, these copybooks with all annotation, also geologies was on there, so get information about geology and geomorphology. And this guy, this Mauro, in the 90s, very young geologist in the field, and the Apennines working, doing maps with colored pencil in the normal way of doing geological maps. In the same times, starts to be the new technology to doing maps, digital technologies with computers and GIS. The first, I think, was the first software that was Archinfo from Esri. And I remember in that ages, I was asked to work on that, but I say, no, I want to go to the field, not to stay in front of this PC. But in the 1999, we had the opportunity to try this tool. Is the first tablet PC was called Pen Computer, because you can use with a pen on the screen, and we bring this in the field, but it couldn't work because the sunlight cannot be, we weren't able to read anything for the sunlight. We use a Bentley MicroStation that is mostly CAD, not a GIS, so it was the first experience, but wasn't so good. But after a few years, this guy called Bill Gates showed that people could be connected everywhere with this kind of tools called tablet PC, and bring the first important improvement in the operating system, that was Windows XP for tablet PC edition. So we can start again to think how to bring computers to work in the field as a geologist. And then after a few years, this war, the second Gulf War, bring computers in the field, the tablet PC in the field, working, and so they developed the hardware, the good hardware to work on that. And in 2004, in Florence, there was the International Conference of Geology in Florence. We presented this first software called MapIt. It was developed by us and a company called Terranova, and these tools work quite well with the tablet PC, with the GPS connected. There was already a good operative system and our software. So we went to the field in this way, good improvement with respect to the first slide I show you. And we try to bring this stuff with a rugged tablet PC connected with a GPS. The connection was with a USB port, so there was also a wire, etc. And we were able also to make a cover, a good cover for this.
Так, щось завис наш Мауро. У нас немає його презентації?
Ми маємо...
Дмитро Миколаївич, треба спробувати з ним зв'язатися, бо він щось... Так, Мауро, ми вас не чуємо.
Sorry, there was a problem of connection. I tried to show again the screen. Where is it? Here. Okay. Okay. Is it working? Yeah. Okay. Yes. Sorry. This digital ink technology allows to use a pen on the screen, and this was quite important to write and to draw like the normal geologists in the field do. And so that was a good way of, sorry, I can, okay. And we can also insert, for instance, pictures and draw on the picture some interpretation like this one, but also write directly on the map, on the aerial photograph, like in this picture. There were some survey. This is a state geological survey of Utah in USA that start to use this software, and they presented also some results in this conference, the digital mapping techniques that is held every year in the USA. So we start also some debates, which kind of software, which kind of hardware can be used in the field, is better to use in the field, etc. So the debate, let's say the scientific debates on that started. It was very good to compare our methods with other methods with other universities that started to work on these topics. We did comparison with GPAS acquisition, etc. And we had many applications. Also, during my classes, I bring my students in the field using these tools and softwares, doing some survey. And there was also some application on our research. This is a village in the south of Italy that is affected by landslide, and we had geological mapping of this area, and we use these tools. But the problem was that the company, this software was a commercial software, so the company say, no, we don't want to develop any longer. So also Mapit quit it. And we had experience. So after a while, we start to collaborate with other people. So with a doctorate, with a PhD thesis, we developed another software, but we didn't start from the beginning, but we use an open source software that we'll see in a few slides. And this software, the transformation of this software was called BGs, with many meanings, of course. And so the hardware now was the rugged tablet PC that we use already, but also convertible tablet PC of the HP. The operating system for this software was any operating system they can use. Of course, the Windows system has more option with this kind of digital ink technology that wasn't developed at the time in the other operative system. And the software was built on UDIG. UDIG is an open source software that we'll see later what kind of development he had. So this was the software, what we see in our computer. We were able to use the digital ink technology to draw, in this case, on this kind of post-it sticky notes. And we can draw freehand directly on the map as well with this stylus. Putting GeoNotes with a lot of information, pictures, and interpreted picture, etc., like we did in Mapit. So we transfer our knowledge to this new software. And we did it also because we had a very important award from HP. In 2008, we had this grant award of $10,000, $100,000. And with many tablet PC, etc. And we can develop a project for education, and not only, also for research. And we bring people in the field with this convertible tablet PC computer. So that was our application on the Alps, on the Apennines, etc., with many students. This was a nice experience with primary school students of my village, of my town, Fermignano, and we bring small students in the roads to map the roads of the town in the OpenStreetMap project. And it was nice because we see that younger students were able to teach to their teachers how to use this software. So it was a really good experience. And also we use the civil protection to share information from the field to the central station. So we had a good experience with some training of rescue people. But also UDIG died because there was no development any longer, and so BGIS died as well. So 2 failures we had, but we learned lessons. So what we had to bring to use computers in the field. So the first thing it was we must keep the traditional way of mapping. Okay, so this kind of pen on paper, in this case on the screen, exploiting the digital technologies was really good. And you had to have minimal digital education like these children in the streets. Another thing is you need a fast acquisition of data and information, because in the field you are not seated on an armchair. And so you have to be fast and simple to make your work, avoiding any problems and having the right human interface. The dimension of the tools, especially other tools, are very important. We improve accuracy and precision with GPIS, but also with taking account the limitation of paper mapping. We try to keep with this method the assessment of uncertainties of interpretation, and also using more dimension than the 2-dimensional maps. We'll see later. Storing, managing all data, and sharing all data, of course, was a really important topic, allowing group work as well. Another thing very important was that we had to put our knowledge and our, let's say, method of working on a robust GIS software platform. So the software has to be well known, very well developed, and must be possibly open source. So we passed to QGIS. QGIS in 2015, we start to use QGIS, and so the ingredients of these procedures and methods were tablet PC, that in this case it is Microsoft Surface Pro tablet PC with a cover that it makes a little bit rugged. And the operative system, you can use any kind of operative systems. If you knew QGIS, you know that you can use it. Now you can use also Android with QField and other development. I see tomorrow there is a presentation on that. It's very interesting. And but I think the main operative system that we can use now is still the Windows system. And the software. The software is QGIS. What we have to customize the software, to personalize the software with some plugins that helps you to work in the field. And we did it with our students. I'm teaching also in the information technology courses, and we had students able to make some plugins that are, some of them are available on the plugins repository of QGIS. Some of other we must adjust in some way, but they will be delivered in I hope so in a few months' time. So this is a BPen, is this sort of pen that you can use directly on the screen to sketch and to write notes directly, or to draw. As if, for instance, this is a landslide that was drawing immediately on the screen and color it in the screen, and then we can be later digitized in a better way when you are in your lab. But you just put some information directly in the very fast way. We had also in the control bar of QGIS, we developed some setting controls for time interval acquisition and also the distance threshold. This is quite interesting for when you use this small GPS receiver. And also we developed geological compass. This not still delivered because we have to work a little bit more. But this is a geological compass for Android devices, and you can bring information from this compass directly to QGIS and also from QGIS to the compass. This is quite interesting stuff. And the application was the use for teaching my field classes. This was just one of our classes. And also application after the last earthquakes in the central Italy. We directly go for civil protection to maps ground effects of the earthquake in the days after the disaster here in the south of my region, the Marche region. And we work with these tools. And now we start to work with a big project involving 5 universities for the reconstruction of this part of the region. And we work on survey landslides that are affecting the small villages. There are beautiful villages around, but they are affected by big landslides. And to reconstruct, we have to work on a survey. And because of we work with many groups of surveyors of 5 universities, there was more than 1,000 landslides to survey. We arrange this method for all the university, creating a good database and also some forms to be filled directly in the field. And these are an example of that we have to work for this mapping, landslide mapping. Another application was to work on some capable fault in the side of my region near here, Urbino. There was a big earthquake 200 years ago, and similar to the one that was affected in 2016 in the central Italy. So I'm working on the faults that were the ground effect of that earthquake, and we work also with drone, etc., putting all together information. And this is a work that you can find more information about method and the workflow. And moreover, if you have already digitized digital data and information, you can use it to work in more than 2 dimensions. So you can start to work on 3D modeling and also 4D modeling, if you like. And this is, for instance, you put information gathered directly in the field with geophysical information, seismic information, or quick FOCI information to make large and deep 3D modeling. Another 3D modeling was done already with digital mapping, using 3D printer, bring to the digital information in a 3D model, and then to be able to print this model, making a volumetric geological map with this plastic material. And was an experiment that now we start to try to do something better. But it was a very interesting and promising experiment doing this work, because it's also a good way of teaching how to read geological maps for students, and not only. And this is a paper that we wrote. It was published just a few weeks ago. You can find more information that I gave you today. But please let me just say some more words about collaboration with Kyiv University. We get some, now I say, good friend, Vitaly Zasarkovny, with his wife Galina, and many of the students. Vitaly here is doing very interesting. I couldn't understand very well because I don't know Ukrainian, but it was really interesting lesson about data information, something that is really important also for me. And this was the students here in Urbino. They are in Urbino and they are attending our classes. And here at field classes we are almost on the mountain, on the Apennines, and we bring students to make a lot of field trips and field activities. So this is field mapping classes. Here, Ivana and Marina from Kyiv doing a very good job. Ivana make a good report of this work that was also published. This is the work of Ivana that was published, and so it was a really good collaboration with also other students here. Ostapenko and brought 2 papers, and here we have another professor, my colleague Stefano Morelli, showing on the tablet PC something about geomorphology in the field classes, also here in the Furlo Gorge all together. And the last slide I want to show you, is the friendship with families, my family with Vitaly and Galina together. Sorry, I felt a very strong feeling with them. It's nice to meet him. I'm sorry for the situation you have. I just wish you peace and safe for all of you. Thank you for inviting me. It's a pleasure. It's a strong feeling for me. Thanks.
Thank you, Mauro. Very interesting presentation. And we can have some questions. Please, questions. Hello, прошу.
Thank you. Can you tell us about practical usage, for example, for prediction of some catastrophical slope or events, or for example?
Oh yes, these tools is thought to get information, to get data in the field. So these are the main topics. But as I show you about these capable faults, these faults will be moved in the next, I don't know when, I hope very, very not soon, but there are faults that can generate an earthquake around. So it's really, really important. We cannot predict directly, but we know that something will happen in the future. So if we know the position and kinematics and other information about these faults, it's very, very difficult. It's very, very important to project things. For instance, we have old towns, old villages here in Italy, beautiful historical villages around, but we have to defend them from the next earthquake, for instance. And if we know where there are the faults, that can be useful to make microzonation of for earthquake, etc. So this can bring very interesting data, information to make this task. Okay, I hope I could.
Thank you, Mauro. We have some questions. Тетяна Машукелі, please.
Hello, everyone. Thank you, Mauro, for such a great topic. It was really interesting, especially to listen about history, actually. I'm not such familiar with QGIS, but I would like to learn more. I'm wondering about BPEN. Is there an option, for example, to use this one in field if there is no any internet connection? For example, I do some scratches, and then when internet appear, I can transfer this to my QGIS project in laptop or personal computer. Is there option for this one?
Yes, for sure. You can use off-grid, you can use without any network. You can bring in your tablet PC all your information. What you draw in your computer is still in your computer. Then if you want to send your information to a group, to the lab, to whatever you like, you can when you are connected. But you can have all your information with you, okay? So, of course, if you have a connection, you can send this information, but you can work without any connection as well, because we know in many areas around in the mountains there are no connection, and so it's important to be able to work as well. So with all the information, if you have a connection, you can also use other maps, online maps, etc. But you can bring your maps as well in your GIS project. So it's the way you.
Thank you.
Thank you,
so
Mauro. And maybe last question in our plenary section is Dmytro Lyshenko.
Okay.
Well, thank you for your interesting presentation. Have you an experience of use QField software on Android?
Yes. When QField was born by Marco Bernasocchi, as a Swiss guy, I called him in Urbino to give a seminar to my students, and we spoke a lot about the development. It was many years ago. Now QField is a really good tool, and we use it. We try to use it in QField as well for this project of landslide in the central Italy. But at least I know, but maybe it's because I'm used to work with QGIS. When you use QField, you have to export to QField, then re-import to QGIS.
Yeah.
We work directly in QGIS, you know, and so you don't need to make all these export import in all your machine, etc. So your project is still in your tablet and also in your desktop, the same. Okay, you don't have to make a lot of translation from one to the other. Sometimes there is some problems, but in some cases, it's quite interesting to use QField with smaller tablet, for instance, when you don't have. One thing that I didn't say, why I say just that it's important to have a right human interface. For instance, I think that the dimension of the screen where you can draw, it's really important. It's too small. I'm not able to draw in a very small area, in a stamp area, you know. But if you have the right size, you can draw, you can write, you can do many things. So I tried many devices, also on smartphone, etc. But I think if you want to do the right geological mapping, you must use some kind of tools. But if you need to get just points with data, etc., you can use also the smartphone. No problem.
Так, мабуть, вже все. Теня.
Коротке запитання.
Бачу, питань багато може бути, я зараз бачу. Давайте, колеги, у нас вже закінчився час, але давайте 30 секунд. Добре. Тоді Ксенія Бондар. Перша, а потім Володимир.
A short question. How do you think, what's your forecast about the development of these computer technologies used in the field for the next, let's say, 10, 15 years? Maybe some augmented reality?
It is not short question and short answer, please.
Yeah, yes, it's for sure. There is very, very fast improvement in these technologies. So I'm quite sure. Just I gave you something about methods and procedures. That's very important. Then later, the technological side will be developed very, very fast. So I'm sure there will be a lot of things to do later. Okay. Okay, I hope so to be a quick answer.
And the last question, Volodymyr Seprekin, прошу.
Please shortly summarize the best hardware and software for working with maps in the field.
I show you. I just show you. For us, it's this is Microsoft Surface tablet PC are really good with Windows, and the software we use is QGIS. It's QGIS, and it's really handful, and we were able to do many things with that. In many
What about Panasonic tablet or Dell tablet?
Of course, you can use all of them, but in my experience, in my experience, when I have to say to the university to buy a tablet PC for my students, is that one. It's not so expensive. It's really, yes, it's a little bit expensive, but not like the rugged one. And it's really useful. I say I use that from many years, and it's good. But of course, you can use all of them. HP were very good, but I would say not. I want to buy now that kind of HP convertible tablets that we had at the time.
Thank you, Mauro. Thank you, participants. Thank you, lectors. At the end of our plenary section, we will wait you in a special section after break.